Hi, I'm George Woodbury from College of the Sequoias, and in this video we're going to talk about the eccentricity of an ellipse. Now the eccentricity we calculate by dividing c by a. Remember that c is really the square root of a squared minus b squared, so it's going to be smaller than a, and so this is always going to give us a fraction, a ratio between 0 and 1. The closer it is to 0, the closer the graph is to a circle. And if you think about a circle, if we write the equation for a circle as if it were an ellipse, a squared and b squared would be the same, so c would equal 0 for a circle. The closer a and b are to each other, the closer that's going to be to 0, the closer it is to a circle. And the farther away is from B, the less circle-like. That's going to be more ovally, let's say, more stretched out one way or the other. So in this first problem, we've got x squared over 49 plus y squared over 4. A squared is 49, the larger of the two denominators. B squared is 4. So C, in this case, would be the square root of a squared minus b squared. That's the square root of 49 minus 4, or the square root of 45. Now, if we're trying to do this exactly, we should simplify that before we divide it by a. E would be 45 is 9 times 5, so we can get a 3 out of there. 3 radical 5 over a, which is 7. And we can tell that that's going to be more than 6/7. That's going to be up in the 0.9 area. That's closer to 1. That means that it's less circular than, because A is so much bigger than B. But if we wanted to come up with an approximation, we could use that, or we could have just used the square root of 45. Let me show you both. Go into the Desmos Scientific Calculator. Let me just get everything out of the way. We could do fraction radical 45 over 7. That's 0.96. We could also have done a fraction with 3 radical 5 over 7. Again, 0.96. So this time, E is approximately 0.96, and notice that's really close to 1. It's as uncircular as an ellipse gets. For number 10, it's not in the right form yet, so I need to divide both sides by 900 so that the right side is equal to 1. That will tell me what a squared and b squared are. Then I can find c, and then I can find the eccentricity. 36 divides into 925 times, and 25 divides into 936 times. So we've got x minus 7 squared over 25 plus y plus 2 squared over 36 equals 1. A squared is 36. B squared is 25. So B and A are 5 and 6. Those are closer together. We would expect a lower eccentricity. C is the square root of a squared minus b squared, which is the square root of 36 minus 25, which is the square root of 11. That's somewhere between 3 and 4. We're going to put that over a, which is 6, in a minute. The eccentricity is square root of 11 divided by 6. And one last time to the Desmos calculator, fraction radical 11. In the denominator, we've got 6, and that's 0.55, so much lower than we saw in the last example. Right, that is it for ellipses. In the next batch of videos, we'll be talking about hyperbolas, the last of our conic sections in this course.